Hello everyone, my name is Darko and I'm here to teach you about the usefulness of CoffeeScript. I've been using CoffeeScript in most of my projects in the past few years, and in this course we're going to learn how to build a note-taking / document editing application with a twist, making it our own and customizing it in any way we see fit. The first few chapters might seem a bit tedious, since they'll revolve around the language and the concepts we will use in the app, but I promise this will get interesting pretty fast. So without further ado, this is the CoffeeScript documentation. We'll be using it as a guide and as a reference manual throughout this course. First of all, let's get acquainted to the language and what's it about. CoffeeScript is a language that compiles, or rather translates to JavaScript, but fixes most of its shortcomings and adds some additional goodies on top, varying from syntax sugar to an actual class implementation in the language. As the introduction in the documentation says, it's just JavaScript, but with some of the pains of using it taken away, abstracted from the developer. Before getting down to writing, we should make a couple of notes regarding what CoffeeScript offers over JavaScript at a glance. Less code usually means less to read, easier to understand, and easier to maintain as a consequence. This doesn't strictly apply to the volume of code alone, but in this case it often does. CoffeeScript does all that. It is quite similar in syntax to JavaScript, but needs less code to achieve the same results. In other words, it is generally less verbose than JavaScript. This is best seen through the class syntax in the documentation and the resulting JavaScript code. As we can see from the example, the JS side of the code is quite a bit bigger and harder to read. Additionally, it uses only the good parts of JavaScript as specified by Douglas Crockford. If this topic interests you, you can visit http://javascript.crockford.com to get a deeper understanding on the subject. In a manner of speaking, it can be seen as a sandbox JavaScript, abstracting you from the potential pains of developing web applications using it, while adding a lot of goodies on top. So let's see some of these in practice. From the example shown in the documentation, we can see some variables, functions and object declarations, execution of some functions, and an array comprehension. If this sounds confusing, that's perfectly okay. All of them will become familiar as we progress through this course. First off, let's get acquainted to the embedded examples in the docs and how to use them. Below each example, in the right corner, there is a green button that says Run Something. These execute the examples, showing us what the code does exactly. This will prove rather helpful in our future lessons, as this course is focused on the practical side of CoffeeScript that is not focusing on theory too much. The documentation should always be used as a reference manual when things get confusing. Each section is conveniently linked in the top menu for ease of access. What we currently see in front of us is the JS to Coffee page. It's one of the most useful tools for JavaScript to CoffeeScript migration available. However, we'll make an additional use of it. It is going to help us learn the basic differences between JavaScript and CoffeeScript. Before we start, we need to select the second tab, Coffee to JS, in order to select CoffeeScript to JS compiler instead of the JS to Coffee conversion tool shown on screen when we first opened the page. Let's start with the basic examples shown within the CoffeeScript documentation, in no particular order. As you may already know, variables in JavaScript are declared in the following manner. Its equivalent in CoffeeScript would be compiling this statement, as we can see from the right-hand side of the screen, produces a similar code to what we would usually write by hand in JavaScript. The first obvious difference is the need for compilation. This is of course an additional step in the development process, but it isn't necessarily a bad one or one that slows you down, as we will see further along in these lessons. Back to our example, we can see that CoffeeScript doesn't use semicolons for line termination. The compiler actually takes care of this for us. Additionally, we can see that it doesn't use the var keyword. This is also taken care of by the compiler at compile time. Take a look at something a bit more advanced. Object declaration. As you may already know, objects are one of the most important parts of JavaScript. Case in point, JSON. Objects in CoffeeScript are declared as follows. The compiled version of the example, again, resembles what we would write by hand when declaring an object in plain JavaScript. This brings us to yet another difference. CoffeeScript uses significant whitespace, spaces, new lines, and indentation instead of semicolons, colons, and in some cases braces and curly braces. The indentation part is where the magic happens. In this particular example, we can even omit the indentation, and the compiler would still be able to handle it. However, this is a widely accepted way of object declaration, so we will try to follow it. The resulting code is the same if we use the same syntax like in JavaScript. We will get a more clear picture of why this is so in the following lessons. After objects, let's take a look at JavaScript's first class citizen, functions. The syntax is of course significantly simpler in CoffeeScript, following the examples in the documentation. Running this through JS to Coffee gives us the compiled equivalent, which likely looks familiar. So let's see what exactly happens here. Curly braces are omitted, which we are already familiar with from the previous example. This is the case with function definitions as well. The x surrounded by the braces would be equivalent to the arguments of the function. Following that is the arrow operator, which tells the compiler that there is a function following it. It's worth noting that whether we use a new line here or not isn't of much consequence, as long as we follow the rules of the CoffeeScript syntax. Now comes the part of what the function actually does, provide us with the square of a given number. As we can see, the multiplication operator is used to achieve this, much like JavaScript. The important part, however, is that the CoffeeScript compiler prepends a return statement before the last line of every function. In most cases, this allows us to have a cleaner and more readable code. One more thing to note with function declaration is that, if a function has no input arguments, we can freely skip the parentheses part, like so. This code will alert the string inside the function. We should note, however, that when we are calling a function, we can't skip the parentheses if the function has no input arguments. Hand in hand with functions, we have scope. Scoping is handled a bit differently in CoffeeScript, as we can see from the example in front. This is so in order to avoid the confusing scope behavior of JavaScript. From the compiled code, we can see that the compiler takes care of this for us. Additionally, each compiled CoffeeScript file is always wrapped in a self-executing anonymous function, or functions that are wrapped in parentheses and executed immediately after declaration. That helps us avoid polluting the global namespace, which is widely considered to be a bad practice. We'll try to follow good practices during the course, but it's good to know from a theoretical perspective. In the following sections, we will learn about one additional operator, the fat arrow, which will help us further untangle and clarify some code. Before continuing to the next video, where we'll compile our first CoffeeScript file, remember this. The documentation is our best friend when learning the language. We'll look at it often, and it will serve both as a learning tool and a reference throughout the course. In order to continue, we'll need a working copy of the CoffeeScript compiler installed to our machine. CoffeeScript requires Node.js and npm as dependencies. Node.js is a technology that allows us to use JavaScript on the server, while npm is the package manager for Node.js code. Installing this is already covered extensively. As a starting point, for Windows, download and run the Windows installer, provided at http://nodejs.org/download. For Mac, you can download and run the Mac installer at nodejs.org/download. Alternatively, it can be run via Homebrew. For Linux, download and build the appropriate package from nodejs.org/download. Additionally, many Linux distributions already have the version of Node and npm within their package managers. You can also install it from them. Note, however, that we are going to need a reasonably recent version of Node.js in order to make sure everything works as expected. Once this is done, we install CoffeeScript by following the instructions in the documentation. Please make sure you complete the setup and have a working version of CoffeeScript on your machine before continuing. We can ensure this by running the command coffee in the command line as shown on screen. If everything is okay, we should see the text coffee on screen. Now we dig a bit deeper into CoffeeScript. We are going to compile our first CoffeeScript file and then run it in a browser. For starters, let's just create a simple function that will alert Hello World, as is a tradition when starting with a new programming language. This looks good. Now, let's compile our file and run it in the browser. First, we need to run a terminal. In Windows, this is done by start run cmd. In Mac and Linux, this program is called terminal. We simply need to run it. On Mac, we can start it via Launchpad, while on Linux this is often found in the launcher of your desktop environment. Once there, we should navigate to the directory where our file is located. Executing coffee -c on the file name will produce a JS file we need to run in the browser. From here on, it is a simple matter of including our JS file in a simple web page. What remains is to run our file in the browser of our choice. And congratulations, you just got your first CoffeeScript file running. With that complete, next we'll take a look into the tools and ecosystem of CoffeeScript. In the previous video, we compiled our first CoffeeScript file and ran it in the browser. Before taking off and celebrating this grand occasion, we should take note of Cake, CoffeeScript's companion task system. It is a tool that takes care of automation with the various menial tasks surrounding CoffeeScript. Cake is explained well in the documentation, so I will just show a quick example of using it in action. This is a Cake task. Now, we'll navigate to the directory we want to compile files in, and run Cake compile. As we can see, this produces .js equivalents of every .coffee file in the directory. Cake files are used for automating tasks such as compilation. More examples and instructions on how to use them can be found on my GitHub page dedicated to this course, located at github.com/dobozinovsky/CoffeeScript course. That wraps up our overview of Cake and Cake files, which we'll use as a convenience through the course without getting too deep into their syntax. However, you can always take a look at the documentation and the examples provided in the repo if interested. See you next time, when we'll dive deeper into CoffeeScript and its object-oriented nature. Hello again, folks! In this lesson, we will delve deeper into developing a real-world CoffeeScript application. As previously mentioned, we are going to build a note-taking/document-editing application which is going to be easy to customize and adapt to our needs. Think of it as a starting point to build something of your own, usable in a way you see fit. What you currently see is my GitHub repository dedicated to this course. In order to make things a bit easier for everyone, I've prepared a couple of templates, examples, and other goodies that can be used as a companion to this course. As we can see, there are a bunch of files and folders over here. These are exactly what our project is going to look like. We'll get to work on these in a few minutes or so, but first let's take a look at some things that need to be explained before writing any code. One of the major differences between JavaScript and CoffeeScript is the presence of classes. In case you're not familiar with classes, they can be defined as constructs that are used to describe something, a user, an animal, and so on. They contain both data and the ways to manipulate and are used as a tool to model real-world or abstract objects. Additionally, organizing our code into logical entities makes sense from multiple standpoints, navigation through the project, maintaining it, debugging, adding new functionality, etc. That's why this project will be following a development paradigm known as MVC, Model View Controller. This probably sounds familiar already, as it is the de facto standard for application development. Of course, MVC isn't a silver bullet and definitely doesn't solve every problem under the sun, but it does make sense in our use case, our note-taking application. That's why we'll be structuring our project in that manner. Again, we refer to the documentation for a better understanding of how classes work and what they are about in CoffeeScript. As we can see from the example, it defines a simple class called animal. This example shows exactly what we went through before, creating a custom type which we can later use as we see fit. Before going further and explaining how extending classes work as shown in the example, we should understand how classes are translated to JavaScript at compile time. The compiled code, clearly visible on the left-hand side, shows us that CoffeeScript classes are in fact equivalent to JavaScript functions. As JavaScript uses prototypal inheritance and functions are JavaScript's bread and butter, this is only logical. So let's go through the syntax and explain what part of it does what. Class animal simply declares the class. Appending a new line after the statement is where all the magic happens. The constructor function, or method as they are referred to when in context of classes, is a special function that is used to initialize our class. So when using new animal, this function gets called first. The statement constructor @name arrow needs a bit more explanation. This is equivalent to constructor name arrow @name equals name. It is a convenient shorthand when we need a constructor just to set variables. Additionally, the operator is actually a shorthand for JavaScript's this. So anywhere you would use this, you can instead use except for a constructor shorthand. Move is the last thing of interest here. In this example, it is a method of the class that makes it do something, in this case move the theoretical animal. To wrap this part up, we went through the basics of object-oriented programming and basic understanding of classes. Next we'll look into MVC and some more advanced object-oriented programming concepts. Let's take a deeper look into OOP and MVC in particular, which will give some structure to our project. We'll use something called MVC, as mentioned earlier, to give it a bit of structure. If interested in learning more about MVC, you should start here. Using MVC will help us with building our note-taking application in a clean way, allowing us to extend it in any way we see fit. Without getting into a lot of theory, let's just see how our project is organized. We can see a bunch of directories, but the src directory is of particular interest here. It contains, or rather, is going to contain our code. What we can see inside it are some files and more directories. Of particular interest are the following: models, views, and controllers. Starting with the models, they are a description of our data. They can be users, documents, etc. Their job is to receive, retrieve, and store data. Additionally, in some cases, it is used to notify the other layers in our application about the changes that happen to it. Controllers. To cite Wikipedia, can send commands to its associated view to change the view's presentation of the model, for example, by scrolling through a document. It can also send commands to the model to update the model's state, for example, editing a document. This has been the subject to various interpretations, especially in the context of web applications, but we will stick to this definition as much as possible. Put in another way, the controller is the glue between the other layers of our application. Views. They generate output to the screen. This is the layer that's closest to a user of an application. Looking through the repos directory structure, we can see that our document editing application is organized following those conventions. Next up, we get to work on our project. Before doing any actual coding, we need to obtain the template from the page. There are two ways of doing this. Download it as a zip archive by pressing this button, or cloning the repository via GitHub, or if you're familiar with how GitHub works. This isn't a requirement by any means, but it's always a good idea to learn about it, as it's one of the most useful development tools available. If you're interested in starting with GitHub, this is a good place to start. help.github.com. Moving forward, place the project in a location of our choosing and make sure you remember it, as we will need to access it through the command line. As you can see when opening the files in a text editor of your choosing, all of the files are empty. This is on purpose. We are actually going to write each and every one of them ourselves as a part of the learning process and create a usable application in the end. For the time being, our prototype classes are going to be empty files, which we will be filling with code in the following chapters. We'll be doing this in order to give our app some structure and get acquainted with the directory structure of the project. We'll begin with our base classes, as they will provide the foundation for all other classes that we'll write further along the course. From what we've seen so far about declaring classes, we will now create our first. In the src models directory, there is a base.coffee file. Now, open this one and we'll give it some content. And congratulations, you just created your first class in CoffeeScript. Granted, this isn't much, but as you'll see, this is how all classes start, so it is of real importance. Additionally, the model class is going to become the basis for our storage layer, or the place where we are going to store the documents and the nodes from our app. Now let's repeat this with our other base classes located in src controllers and src views folders respectively. Our views class will provide the basis for what happens on screen when the app is used, and the controller will essentially serve as a glue between the model and the view. Similarly here, we'll edit those as well. Similar to the animal example, this compiled to code similar to what we saw in the JS to Coffee example. Check it for yourself to make sure, and as an exercise of using page. Now that we understand the basics of MVC, we'll move on to using inheritance so we can reuse our code more efficiently. Let's take a closer look at how we can use inheritance to simplify our project and reduce code noise. Now, as a last point of interest in the basics of classes is inheritance, or the extend keyword we skipped in the previous part of the video. It will allow us to make our code more concise and avoid repeating ourselves by rewriting the same code in multiple places. The extend keyword gives us the ability to reuse our classes. As the example states, the classes snake and horse extend from the animal class. Or rather, we can understand it as horses and snakes are animals. One major point of interest here, the super keyword. This keyword tells the function to actually call the parent class function of the same name. As we will see further along, this can often come handy especially with constructors. Additionally, when we are extending a class, that class inherits all of the ancestor's methods. So, if our animal class can move, so can all of its children classes. Snakes and horses can both move. Let's put this into practice. Let's open a document model file located in src models. By now, you probably figured the naming convention our models, views and controllers will follow. As an exercise, you can write these class prototypes yourself, following the examples located in the repository. These are largely trivial, but are a good starting point and give you some training in writing CoffeeScript code, so I would suggest you actually write these yourself. If anything goes wrong, the code in its various versions is available at my GitHub repository. Additionally, there are some pre-made cake tasks in the project that are going to help us with compilation. I also suggest reviewing these. You don't necessarily need to understand them to fully use them. For example, to compile the project and prepare it for use, execute cake compile. All of the boring work will be done automatically. If it so happens that I caught your interest when talking about good practices and patterns, here's something extra to follow. The CoffeeScript documentation resources section. There are a plethora of these out there concerning the theory and various other aspects of CoffeeScript. You can find more of these in the GitHub repository. These days, JS frameworks and libraries are a dime a dozen. While arguing which is better is largely a matter of personal taste, one quotation pops to mind when thinking about writing real-world apps. If you aren't using a framework, you're writing one. This might be paraphrased, and I don't accurately remember who said it, but it is 100% true. However, the idea behind the course is to give you an inside-out view of how modern web apps are built using CoffeeScript. You may be interested in exploring these frameworks and libraries yourself, and this page is a good starting point. One more resource of note would be todomvc.com, which is a tool that can help you choose which one suits your style best. To sum it up, when done with this course, you will be prepared to rewrite this project by using one of these MVC frameworks available. So to wrap this chapter up, what's left is to build and run our project. Open the console, navigate to the project directory and execute cake compile, as shown on screen. This will build everything for us. Next up, we open the index.html file located in the public directory in the browser. And there's the beginning of our application. It doesn't do much yet, but that is about to change, starting next chapter. This wraps up our dive into oriented programming, model view controller, and inheritance. This will begin to show their usefulness and real power in the following chapters. Thanks for watching, and see you next time when we get started on the core concepts behind data abstraction, storage and models, the M from MVC. Hello again, and welcome to the chapter of the course where interesting things start to happen to our app. This time, we'll focus on the data storage layer of our application. When we're done with that, at the end of this chapter, we will have a solid foundation for what comes next, the more visual and arguably more fun aspect of application development. Modeling our data properly is literally the core of an application. Whenever we take an action in an application, it gets translated to some sort of data in the background. Whether that's data retrieval, saving something or deleting something, it comes down to the storage layer in the end. Storing data can be done in various ways and for various purposes, but we'll focus on permanent data storage in this course, as it makes the most sense for our application. The data that we are going to store through the classes we write in this chapter are exactly the documents and notes we'll be creating later on through our views. First off, let's get acquainted to the storage solution we'll be using for our application, the Local Storage API. Local storage is a relatively new way of storing data, and fortunately it is supported in all modern browsers. As we can see from the chart, even Internet Explorer supports it starting version 8. While supporting older browsers is out of the scope of this course, it can be easily done using any of the many fallback solutions available on the internet. Our goal here is to use the Local Storage API as a connection between our classes and our data. While our model classes give structure to our data and provide the methods needed to manipulate the data, local storage stays in the background. This sort of abstraction has many advantages, as we'll discover later in this chapter. In order to better understand why we'll be using local storage, we should first take a brief look at the alternatives, with the notable exclusion of the API approach, which we will talk about later. Additionally, I should note that we won't be considering cookies a proper storage solution. For our application, what they offer in size is simply too little to even consider. Back to the table in front of us, we can see that local storage, listed under web storage, name-value pairs is the most widely supported kind of local storage. This should be a reason enough, but let's delve a bit deeper into the issue. two other entries listed, WebSQL and IndexedDB, have a somewhat curious browser support. WebSQL is unsupported by Internet Explorer and Firefox, while IndexedDB is unsupported by Safari. This is due to philosophical differences between different browser manufacturers. The other two proposed solutions are more sophisticated and flexible than local storage, but until any of them is supported by all, our best bet is to stick to local storage. For a detailed explanation of how the various in-browser solutions work, you can refer to the page we're currently looking at. Moving on to the more practical part of this chapter. What you currently see is a web console. All modern browsers have one. It is usually accessed through a web developer menu or through keyboard shortcuts, most commonly F12 or Ctrl-Shift-I or Ctrl-Shift-K. This page might come in handy when looking for the shortcut for your browser. We'll need the console to test how local storage works and write our classes more easily afterwards by understanding what actually happens when we call a particular method of local storage. The two methods that are important to use currently are getItem and setItem. What these do is rather obvious by their names, but let's see what they do in action. Calling local storage .setItem key value stores the string value under the key key. Retrieving this data is done through local storage .getItem key, which returns value back. This data survives browser reloads, which is of big importance in our case. These were all in JavaScript to get us acquainted with the API. Now let's see how these are done in CoffeeScript. In this particular case, the syntax isn't much different from JavaScript, namely local storage.setItem key value for storing and local storage getItem key for retrieving. As we can see, the only notable difference is the omission of semicolons and braces. Before moving onward to writing our models, we should briefly focus on the more traditional storage method, sending/retrieving data via AJAX to and from the server. This assumes a server component, which is out of the scope of this course. However, this is rather simple with our architecture. We'll be wrapping the storage layer, in our case local storage, in a class to allow easy replacement of local storage with an API. An example of this can be found in the GitHub repository, with some more in-depth explanation. This wraps up our introduction to the storage options on the client. Next we'll look at how to use local storage in our application. And now for the fun part. Let's write our classes. The class prototype should already be in place and the project templates obtained from the repository. We begin by creating a database wrapper class located at src utilities storage.coffee. Get function of key json.parse local storage getItem key. Set function of key value local storage .set item key json.stringify value. We should first note the @ notation before methods in this class. Methods prefixed with @ are known as static methods, meaning we won't need to instantiate the class to use them. This is quite useful sometimes, as we only need one instance of the class to exist at any given time. So, instead of using storage equals new storage and then the storage.getMyKey, we instead use the class directly. Storage.getMyKey. The usefulness of this approach, wrapping the storage solution, makes it easier to later migrate our storage layer to another solution if needed, as is the case with the previously mentioned API. Next up is our model class, which is going to provide the basis for the rest of our models. The model class contains two methods so far. The constructor method, which we've previously discussed, which in this particular case sets the key variable and retrieves the record associated to that key. We'll be storing data as JSON, JavaScript object notation, formatted string, because local storage doesn't support any complicated storage schemas. For reference, please take a look at http://www.json.org. Storing data as JSON solves this, as JSON gives us the necessary tools to patch this in a manner of speaking. The on method here allows us to return all of the records associated to a particular model. The value we return is the JSON parsed version of what we retrieved through our storage class in the constructor. Besides these methods, each of our models will have 4 basic operations: create, function of record, read, function of ID, update, function of record, delete, function of ID, unless data of record .id at data of record.id equals record, return true, false, return at data of id. If data of id false, if at data of record.id at data record.id equals record, at persist, return true, false, persist if at data of id at data of id equals null, delete data of id, persist, return true, false, persist, function storage.set at key at data. That does most of the groundwork for our models. Before moving on, let's review the methods we just wrote. Our create method expects a JSON input which contains an ID. An ID is a unique identifier that helps us retrieve records. More on how we'll create those later. We run a quick check of whether the addData.json that belongs to our model class is unique by its ID or not. If everything's okay, we write it to the storage. Read works by looking for a given ID through the data object of the class. If it finds one, it returns it. Otherwise, it returns false. Update works in a similar manner to create, with the difference that it overwrites an existing record instead of appending a new one to the object. Delete simply destroys the given key of the data object and persists the change. We also added one more utility function, the persist function, which helps us store the changed data object after each data manipulating method. Next up are our document model and category model classes. Writing them will be really simple since we did most of the work with the base model class. These two classes are going to represent the two data abstractions in our app, as the name suggests, documents which we will later divide into categories, kind of like folders. These classes are going to work with the data that comes from the upper layers, view and controller, and send it into local storage. And that wraps up our model classes. One of the boons of using this approach is that we avoid the need to rewrite code with some clever inheritance techniques. Basically, we tell both our model classes to simply copy the methods of their parent class. indicated by the keyword extends, and just write their key in the constructor of the parent class, calling it with super. Calling the super function like that initializes the parent class with the given parameters, in our case the key, which tells the parent where to look for the record. So to test this, let's first build our project and return to the browser console. Visually nothing's changed, but let's see what happens when we use our classes. Document model equals new models dot document model. Document model dot all. As we can see, we can instantiate our models and can manipulate data through their methods. All of our methods work as expected, and while this doesn't seem as much now, it will in fact become the core of our application later on. One of the more important aspects of data manipulation is validation. We avoided it until now, but it's always a good idea to validate input before storing data. For some examples on how to do this, please consult the course repository. To wrap this chapter up, let's recall what we learned today. Storage options, models and model classes, and persisting our data. Thank you, and see you in the next chapter, where we'll be getting started on routers and controllers. Hi again, guys! In this section, we will finally give our application a face, so to speak. This section mostly focuses on stuff that happens on the screen, with our application's view layer, with the accompanying router and the controllers. We'll cover more about these in a moment. Before we dive in, we should go through the concept behind controllers and views, as well as a short introduction on routers and why we need one. Just to repeat the theory, in MVC, controllers were the glue between models and views, notifying the two for changes. The view represents what we see on screen. We add the router to the models and the views, which tells the application what to call when. In our application, we can see the router as a controller's controller, the component which tells the controller what to do when a route is requested. A route, on the other hand, signifies the path that the application logic should take, or rather, execute in order for something to happen, adding a document, changing what we see on screen, etc. There are a lot of routing libraries out there, but to avoid adding unnecessary complexity to our application and understand routers better, we will write one ourselves. However, I encourage looking through the available routing libraries in order to get a better idea about routers in general. As a starting point, visit http://microjs.com, which contains a plethora of libraries including various routers. Without getting into great detail, modern routing solutions usually follow the hash change event or use the push state API. Both rely on URL change. This is due to the fact that what we see on screen whenever we open a web page is determined by the URL we visit. Changing the URL changes the page. Following that logic, it is natural to adopt that behavior to single-page web applications, as is the case with our application. Our router, however, will not follow the hash change event or use the push state API. Both provide a mechanism to track the change in the browser URL, although in different ways. More on these can be found at the Mozilla Developer Network, https://developer.mozilla.org. We are trying to keep it simple, so our router will simply have mappings to our controller classes and call them when necessary with the appropriate parameters. Now that we are acquainted to the various layers concerning the visual part of our app, we'll take a closer look at controllers and routing. We got to know more about the theory behind routing, controllers and views in the last part. Now we'll take a closer look at the router and controllers in our app. Our first step is to create a router class. Our router consists of route definitions, which are actions bound to keyword. They are executed by our controllers, which we will write shortly. Each of them will have a mechanism to call actions defined by the static function call. We should take note of the splat notation here. It allows us to tell CoffeeScript that it should expect an indefinite amount of arguments, kind of like a named array. We'll pass these to the controller function bound to the route in question. So for example, when we call the documents route, the document controller list function gets called with the parameters we specify when we call it. Since we don't know how many arguments there will be beforehand, we use a splat here. Adding new routes is as simple as defining key-value pairs in the routes object of the class. Next up is the creation of the controller class, which will be the base for our other controller classes. Each of our controllers will have a model and multiple views. These models and views need a way of associating themselves to their controller. This is what the init method does, and it will be shared by the rest of the controllers. What we see in our document controller are the same methods described in the router, and what they do is pretty self-evident. Additionally, we have two more methods that take care of the actual updating and storing new records through the model. All of these methods will be later utilized by the view classes referenced here. We wrap up the part about controllers with a similar controller that concerns categories. This class is pretty much a copy of the previous one. I've written it like that on purpose. As an exercise on inheritance, try to cut down the code in both classes by moving the shared codebase to the base model class. If the exercise becomes too confusing, you can always check out the solution in the repository. It is important to try it yourself in order to get a better understanding of inheritance. To summarize the material, we learned about routing and controllers and how they are used in our app. Next up, we'll take a look at views and templates. Now that we have routing and controllers covered, we'll take a look at the views, the part of the app that shows the graphical user interface to the user. This is where we start writing the code that concerns what we see on the screen. As was the case with the previous classes, we'll first write a base view class. Our basic views code will be shared by the rest of our views, similar to the previous base classes. The view class has two methods. One is the constructor method, and the other one is the render method, which will be the function that puts rendered HTML markup in the app. The constructor method is a special method in CoffeeScript. It takes care of initializing a class. What that means is that when we first call the class via new, this is the method that gets executed by default. In this particular case, it sets the element which is to be filled with markup and the template we are going to generate that markup from. Next up is the document list view, the part of the app which lists our documents on screen. A few things to note here. As we can see, the class extends the base view class, reusing its constructor and render methods. One new concept that needs to be understood is the template part of the constructor. In the constructor method of the class, we pass it as a function which renders the given input data as specified in the controller action. Inside the template function, we can see one more CoffeeScript goodie, multi-line strings. These aren't supported by JavaScript. In our case, multi-line strings are quite useful for writing templates, as we can see on the screen. We should also note the for-of loop, used to generate the markup from the input data. The for-of loop is another one of the CoffeeScript tools not found in JavaScript, not in the current version at least. It allows us to loop over each member of an array by key and value. In our case, the key is equivalent to an ID, and the value is equivalent to a document we previously stored. Before passing the generated markup forward, we add an additional element, a div, with a class of clear, to avoid breaking the layout in the application. Additionally, we have a bind method, which takes care of the behavior of various actions in the view, in our case the buttons. To simplify things, we use jQuery for element selection and event binding. We have only one possible action, which maps to a controller behavior we previously defined, opening an item in the document view. Next up is the item view, which takes care of showing a single document. The only big difference here is the presence of three distinct actions: edit, close, and delete, which are pretty self-explanatory. Again, this map to controller behavior or calling the router directly, in the case of the close action. We are doing that in order to unbind the events from the close button and avoid memory leaks and weird behavior in the application. This is a slight violation against keeping application layers separated, but we will address this in the following chapters. Last, we have the edit view, which, as the name says, takes care of editing our data. Looking through the code, we can see one notable difference: the presence of a simple input form, which produces documents with a given input. Event-wise, we treat the elements similar to what we do with the buttons, and send the record to the controller for storage. As an exercise, you can try writing the category views, considering a category is defined by an ID and a title. Of course, if the task seems too hard, you can always refer to the repository and the annotated examples in there. Having written some basic view and controller functionality, we should review the workflow. The idea is to have as much separation between the layers as possible. This has multiple advantages. Keeping it modular allows for easier maintenance and provides us with the ability to swap apart completely if we need to. For example, you might have noticed that we still have no mechanism of generating a unique ID for our documents. We can fix this by adding a single line of code to our controller. Record.id equals new date.getTime. This approach has its shortcomings, but in our case serves its purpose just fine. I should note that using this in a production environment is unwise, but since our application runs only on our machine, it should be okay. What remains is to test run our application. So let's compile it and start it in the browser. Now, let's take a look at what our app can do. First, let's try creating a document. Once we add some content and save it, we can see it appear in the document list. From here, we can edit it and add some content to it. Following that, we can delete it if we don't want it anymore. As we can see, we can now store, view, list, edit, and delete documents. We can do the same with categories, of course, but before giving you the code for that, I would suggest solving that as an exercise. The final code for the chapter can be found in the repo, under section 4. To repeat what we learned in this chapter: routers, controllers, views, and events. Next up is in-depth jQuery and CoffeeScript, making our application a lot awesomer. Before we begin this chapter, I should note that it is going to be focused on why we made some decisions in the previous chapters, a bit like a code review. The idea is to get a better understanding of our code and why we wrote it that way. Additionally, we are going to introduce some changes in it as an exercise of sorts in order to get a better idea of how to maintain and edit our code. First off, we are going to take a better look at using CoffeeScript with jQuery. Because we are using a lot of jQuery to perform DOM manipulation, inject our templates and bind events, it makes sense to begin with it. Let's take a look at the file that initiates the application. Aside from declaring our global namespaces, which are later used by our classes and controller initialization, there is the function that binds click events to the links in the sidebar. As we mentioned at the start of the course, CoffeeScript is just JavaScript. The way we bind the click event isn't a lot different to how we do it in JavaScript. It's simpler and less noisy, which allows for greater readability. What happens in the function is the following. First, we catch when an A element is clicked in the sidebar. We prevent the default behavior of the link because we don't want it to take us to a different page. If you recall from our index.html file, the href attribute in the links corresponds to a route from our router class. However, if we don't prevent their default behavior, the browser will simply treat them as links and navigate elsewhere. After we override the default behavior, we simply extract the href attribute from the current target property of the event. The current target property is in fact the element we clicked in this case. Wrapping it in the $function allows us to treat it as any other jQuery wrapped DOM element and access its attributes easily. Last, we trigger the route by executing router.call with the route we extracted from the URL element. Our per-view events are bound in a similar manner to this, but we'll review them a bit later. The view layer is where the on-screen interactions happens. We'll go through a couple of examples of the event binding code we wrote in the previous chapter. The simplest example of this is the document listView class. We should take note of the bind method. Similar to what happens in the app.coffee file, we have a root element that contains a number of li elements. The behavior we want when clicking one of these elements is to open a document it represents for viewing. To achieve this, we refer to the addElement variable, which contains a jQuery wrapped version of the root element of our application. We can find each of our li elements by using the find method in jQuery. That provides us with a list of all matching elements to which we can attach an event. Clicking in our case. As the li element has no default behavior associated with click, we have no need of preventing anything, as was the case in app.coffee. We then extract the data ID attribute of the li element that was clicked and pass it to the controller to trigger some action. The data ID attribute is actually a unique identifier for that particular document and is the equivalent of the ID attribute of a document model. Prepending it with data in the DOM is to avoid confusion with the actual ID attribute of HTML, as well as keeping our markup valid. Please note that data attributes are also part of the browser specification, not simply a convention we are using. In other words, those attributes are considered valid by HTML5 validation tools. Now, on to something more complex, the document editor view. Document editor and document item have similar event bindings, so going through one of them should be enough to gain a firm understanding of the event binding process. Again, the bind method is what we focus on. The thought process is similar to what we did in the document list view, with one notable difference, the presence of multiple types of action. We have the save and close buttons, which have different behavior. As the name implies, we filter these through a switch statement, probing their data action attribute for a hint on what they are supposed to do when clicked. Following that, they perform their associated action. On top of that, the document item view has one more method, the delete method. The reasoning is the same in there. In fact, we'll be able to add more buttons as needed using this approach. And we will extend our application with more buttons and functionality in the following chapters. What's important here is to understand the thought process behind the decisions we make related to events. Next up, we'll take a look at global events and using an event library in our application to make things a lot simpler. I mentioned the #change event in the previous chapters and that we are going to skip using it for keeping track of state. Since this chapter is about interactions and events, it is necessary to mention the #change event as well, because it is used in most modern JavaScript frameworks aimed for the browser environment. The hash change event tracks the change of the hash part of the URL, which is traditionally used to mark in-document links. As we mentioned before, the most natural way to track the web app is by using the browser URL, since the browsers were designed to correspond to URLs first and foremost. While using a browser, whenever we change the URL, it results in the page being changed inside the browser window. Adopting this behavior for tracking application state has many benefits. It won't confuse the users by breaking the back and forward button functionalities, as is the case with our application. Additionally, it is friendlier to SEO. However, introducing it as an additional component in our application would have introduced additional complexity. There are a lot of libraries that can take care of it with some work, but handling that is out of the scope of this course. However, there is an example of how to do this in the course repository. So if this is a topic that happens to interest you, you can use that as a starting point and as an example. Additionally, we should mention the push state API, which is a more modern approach to state handling in the browser. The push state API, in this context, does the same thing we were doing with the hash change event, but without the hash in the browser. This allows for the most natural approach to URL handling, without resorting to hacks to make things work. More on the push state API can be found at developer.mozilla.org. In addition to the local, per-view events, we have something that we may consider global events. For example, changing a route is a global event, as it concerns the entire application and what is shown on screen. Additionally, the way we currently change call controllers from views slightly violates the separation of concerns principle. The principle mentioned is about keeping every layer of our application as isolated as possible. This approach has multiple benefits, but most importantly, we'll be able to swap any part of our application without having to worry about breaking the other parts which communicate with it. For example, we mentioned managing our data through an API previously. In the current state of our app, it is doable, but it requires more work than it should. We'll address this shortcoming by introducing an event emitter utility class, which will help us isolate our application's layers even further. Essentially, we can view the event emitter as the wire by which our layers communicate. This is similar to a phone line in that regard. Whenever something significant happens in one of our views, we can publish that event to the event emitter, and any layer listening to that particular event gets notified of the change. This can be used in many different scenarios, and it is especially useful in scenarios in which we use asynchronous APIs, such as Ajax, timers, etc. For our event emitter needs, we'll borrow a piece of code from the widely known Backbone.js framework. We can write one ourselves, but it is simple and minimal enough to understand on our own. This has already been done, and is exposed globally as event emitter. Our event emitter uses three methods: on, off, and trigger. These methods work similar to their jQuery counterparts, which aren't aimed at the DOM, but instead at custom events that concern other areas of an application. Instead of calling our controllers directly, we'll simply trigger and listen to events triggered through the event emitter. Event emitter.trigger document :update record instead of controllers.document controller update record. Before trying this out, if you get stuck, the solution is available at the repository. Additionally, we should agree on a standard way of naming our events. So each of our events will be named as follows. First comes the entity we are trying to trigger an event on, in our case document or category, followed by a colon, followed by the action we are trying to trigger. While listening for an event, we'll use the following syntax: event emitter dot on condition action to perform. As an example, event emitter on document :update function of record update record in our document controller class. And to wrap this up, in this chapter we took a deeper view of events and their importance in our application. Additionally, we've begun using the global event emitter to simplify things. See you next time, and we'll start extending our application with more functionality. Hello again, folks. This time, we'll focus on extending our application and taking its functionality a step further. This will teach us a couple of important concepts in regards of application development and show how CoffeeScript is easy to read and maintain. In terms of the application itself, we'll add some structure to how our documents are shown and organized. In theory, this can come in handy if we have a lot of documents and we need to search through them and filter them as needed. We'll achieve this by focusing on the categories classes we prototyped a few sections back. First off, we'll enable the categories links in the navigation. Then, we'll modify the document list view in order to be able to filter the documents we are listing on the screen. Finally, we'll make a few quality of life improvements to the UI to improve the overall usability of the app. First off, we'll focus on adding some code to our application, namely, creating the appropriate classes in order to enable the categories links. As we can see from the project template, we have the routes currently commented out in the router class. We'll get to uncommenting this in a bit. In order to avoid errors, because we are still missing a couple of methods in the classes, we'll first need to write all of the methods for the category controller. At init function new models.category model list views.category list view item views.category item view. These aren't too different from what we had in the document controller. Following the logic of the document controller, we can simply define the views we want associated with the controller. Unlike the document controller, we don't need to call a default action. In the case of the document controller, the call to the list function. Next, we'll move to the views. Again, the logic is a lot similar to what we have in the document. Super canvas and a function of data equals unordered list, the class of categories. For ID item of data plus equals list item data ID of item.id close list tag div class title div and item.title. Close the output with a unordered list closing tag and we return output. However, we won't have a need for directly editing or adding categories. We only need to list them. There's always the possibility of extending the application with a manual adding of categories and editing them. However, currently we don't need those. Category creation is a simple matter of filling in the category field in the document creation form. This certainly doesn't allow for great flexibility, but the application is barebones enough to offer the option of adding that yourself without going through too much trouble. Conceptually, we can treat categories as folders of sorts. In our app, categories can contain multiple documents. Folders can contain multiple files of various types or more folders, and our categories will work in a similar manner. Establishing that, we can move on to extending our category list view. As we did with the previous view classes, we defined this view by providing an element for it wrapped in a jQuery selector, along with a function that serves as a template. We add a render method to it, along with event bindings for the view. As we did in the previous chapter, instead of communicating with our other layers directly, we trigger events on the event emitter that our targets can catch and react on. If we build the application in its current state and try to click on any of our categories, we'll get nothing. This is normal, since we didn't define anything that will listen to a filter event. That event is in fact reserved for the document list view, since that's the view that's in charge of showing lists of documents. We'll hook the event in a bit, but first we need to create a way for our document list view to filter documents according to their category. In the last part, we had a look at the theory behind organizing our data. Now we'll put that theory in practice. We have most of the work done, since our render method doesn't especially care how many documents we pass to it. That leaves filtering a subset of documents and passing that subset of documents to the render method to display on screen. In order to completely enable that, we'll need to add some code to the model and controller classes. We'll simply add a getByCategory method to the model, which will look through all the records and return the ones that satisfy the criteria we want, in our case containing a particular category. GetByCategory, function of category, filtered equals object for ID of data if data of ID dot category equals is category filtered ID equals data ID, return filtered. As we can see, this method is comprised of a simple loop which checks whether an article is of a certain category. Next, we add a small change to the controller. We'll add some change to its list method in order to accommodate the need for varying lists of documents. Event emitter on document column filter category function list category. Category if category list view dot render at model dot get by category of category, else. In case we have an input, we pass that input to the model, which attempts to respond to that query. We then render that data. In any other case, we simply render all the records of a given type on screen. With that in place, it's a simple matter of listening for the event passed from the category list view. Finally, we adapt the router a little bit. Placing a check for whether we received parameters when calling a controller or not is the final piece of the puzzle. With that in place, we can now filter the documents of a given category and easily show them on screen. Now, let's take a step back and review what we achieved so far. With a couple of relatively minor changes, we added some functionality that previously seemed unavailable. This is a direct consequence of keeping our application in layers. We can easily add changes and adapt as needed. Of course, this can be achieved with pure JavaScript, albeit with more code and arguably more code noise. CoffeeScript allows us to do the same thing in less lines of code, with improved readability, which is welcome in any complex project. Our project doesn't fall into the complex category, but serves to simply prove the point. So with a little bit of planning and a layered approach, we can easily extend our application with anything we may think of. In the previous video, we extended our document classes with more methods, enabling filtering by category for our documents and notes. Now, to further clean this up, we'll move the list method we rewrote from the base controller to the document controller, since categories are only applicable to documents for filtering. Add list function of category if category list view equals new at views.list list view.render at model.getByCategory category else super. Remember, any class that has an ancestor class can rewrite the methods of the parent. That's exactly what we're doing here, calling a list method specific to the document controller and using the original method as fallback. What remains is giving our application a facelift in order to make it a more enjoyable experience overall. Our current category rendering doesn't give us a hint what category we are currently viewing. Output equals h1 class title close h1 title text category if category. Can easily fix this by editing the render method. If we detect a category being present as an input parameter, we simply render it in the template. Otherwise, we leave the title field empty. We can get the category by overloading our list method in the document controller. So, once we have access to the category, we can show it on screen. The one last quality of life improvement we will do in this chapter is adding a select box in the document editor for selecting categories. This will allow us to more easily select existing categories. Next to the select box in the templates, we'll add an icon that will signify Add New, since we'll want to add new categories when we need them. In order to get our categories, we'll query our category model for them. Once we have them, we attach them to the select box. What's left is adding the event that takes care of replacing the select box with a text input via jQuery in case we want to add a new category. The behavior of the Save button will remain the same, as we do simple element replacement when we press Add, Cancel buttons to the category field. The names remain the same, and the Save button binding seeks the element's value by name of element. With that taken care of, we have a fully functioning application with categories included. We can now easily organize our documents by adding new categories for them, filtering them, or placing them in an existing category. The idea was to get a glimpse of how we can add functionality to our application without investing too much effort. It is worth mentioning that this will get even simpler if we use a framework. Our structure might do its job currently, but there are a lot of frameworks and libraries out there that can take this even further. I recommend checking them out and trying to write an application in one of them to get an even better idea of how things are done in real-world scenarios. We went through some links about JS frameworks in the previous chapters, so you can refer to those links if interested in some additional exercise. So to wrap this up, in this chapter, we added some functionality to our application. We've added more functionality to our classes, most importantly, data lookup and filtering document. See you next time, when we'll add even more functionality to our application, of which the most interesting is rich text editing. Hello again, folks. Last time, we had a look at adding external libraries to organize our data. This time, we'll take a look at making it more usable. In this section, we'll make our application even better by adding some external libraries. The most important chunk of functionality we'll add today is rich text editing. This will open the application to many more potential use cases, such as exporting our documents for usage in a blog, saving them to the desktop, etc. The point here is to use this as a starting point and make something more of this app. Add a personal touch to it, if you will. To avoid confusion as this section progresses, we won't be actually adding any external libraries. In the interest of time, this has already been done for us through the project template for this chapter. However, if you happen to be interested in doing this yourself, feel free to do it. It's quite trivial as a matter of fact. The sources of the libraries we'll be using are specified further into this section. There is a myriad of rich text editors available on the web, in various shapes and sizes. Since we've been trying to keep our application as light as possible, it makes sense to choose an editor library that follows that principle. So, for our project, we'll be going with SummerNote, which you can currently see on screen. For reference, SummerNote is located at http://hackerwins.github.io/SummerNote. It has all the standard functionality of any rich text editor out there. And the part that's important to us, it produces a clean enough output to serve our purposes. Additionally, it comes with a really simple API, so we can easily dive into using it. In order to be able to use it, we're going to first make some changes to our app. In this part, we've covered a use case for a rich text editor in our app. Next, we'll look into integrating rich text editing in our app. We covered the uses for a rich text editor in the last part. Now, we'll look into integrating it into our app. We'll start by editing the document editor view. As we saw on the SummerNote webpage, it requires a div element to work. First, we'll make a small change to the class names in our template, in order to isolate our form elements from the ones provided by SummerNote and its dependencies. Class equals form item. Next, we move some of the template code around in order to make SummerNote behave consistently in both create and update modes of the document editor view. What we need to do next is replace our text area element with a div element to prepare the template for SummerNote. If we now try to run our app, we'll be unable to make any changes to the document content. Fear not, however, this is about to change. Following the instructions on the SummerNote webpage, we now need to slightly change our render method and create a SummerNote instance via the jQuery wrapped element. Output.find name equals content.SummerNote. That element is the div we placed instead of the text area. If we now run our application, we can see a nice editor in place of the uneditable div we previously saw. In order to make things a bit better to look at, we'll set a size for the editor, about the same as our text area. Height 400 pixels. We can now play a bit with the text editor, see what it's capable of. It covers all the basic operations any text editor has, and we can extend it if we need to. SummerNote is pretty well documented and has a couple of examples that might come in handy in case you wish to extend our application further. However, if we try to save our document, our changes are not actually stored. This is due to the methods we use to store the data. Back to the SummerNote documentation, we can see that it doesn't actually use the val method from jQuery for setting and getting values. Instead, it has its own method, code. This works in a similar way to the val method of jQuery. The code method works similar to val without a value. It gets the contents of the rich text editor. The code value method works similar to val when called with a value. It sets the content of the rich text editor. What remains is to replace all the instances of val that were related to the text area we removed and use code instead. .code name equals content, since it's no longer a text area, and also name equals content and code. We now have a fully functioning rich text editor in place, which is extensible if needed. This opens many options, some of which we will explore in the rest of the chapter. In order to make preparations for the next and final section of this course, we'll now explore a couple of use cases for our app. By using some HTML5 magic, we can use our documents on our desktop in some commonly used formats. So one of our goals is to export our documents as .pdf. This might come in handy if we ever need to use our documents in a different software, send them as files, or even print them. Additionally, we may want to copy the contents for usage in a blog or sharing it on the web. We'll cover this as well. Before addressing this, we'll need to make use of an additional library, JSPDF, which can be found at http://x/products/jspdf. As the name implies, it covers the document exporting part, while the part where we export it for web sharing will be covered in the next section. Now that we've integrated rich text editing into our app via using SummerNote, we'll take a look at exporting the documents to our desktop. Last time, we integrated rich text editing in our app by using SummerNote. Now, we'll look into exporting our documents to the desktop. Before we begin, we'll go through the JSPDF library briefly. JSPDF, as we can see from the example, is able to take HTML as input and give us a PDF document as output. This is still an experimental feature of the library, meaning that we won't always get the output we like, formatted as we expected. This can be fixed by traversing our document manually and adding the contents of the output document, but more on that in a minute. Before we start using the library, we need to place an export button in the document item view. We can put this anywhere really, but we'll place it in the item view. We'll just create a new button element in the template function, create an event binding for that function in the bind function. Data action equals export when export the document. This binding will be where all the magic happens, allowing us to export our document as PDF. First, we need to initialize the JSPDF library. Doc equals new JSPDF. As was the case with previous external libraries, this one is already included in our project. Doc.from HTML at element.find article.html. We then select the element we want to convert to PDF, in our case, the article element. 2020. Following that, we set the document properties and width, 110, height 297, handlers equals empty object. We'll set these to standard A4 format. This can be easily changed to fit any format. Finally, we'll introduce the logic to download the generated PDF to the desktop. Once again, by using an HTML5 feature, to download the attribute of the anchor element. Link equals document.create element A. Link.download equals add element find h1 text.pdf. Link.href equals doc.output data URI string link.click. Now, let's try it out. We have a small typo there. And from HTML. Export. And we can now export the file. Once we press the button, we are prompted for a place to save the PDF file to. Once this is done, we can view the document as PDF on the desktop. This concludes the export part for this chapter. The solution is far from ideal because it can't handle every HTML tag properly. For example, links are removed, styles have to be configured separately, etc. However, if we need something more sophisticated, we could always traverse the document content manually and add those blocks inside the document. You can do this as an exercise. Make the PDF output more sophisticated than its current state. It's worth mentioning that we can convert and export our documents to the desktop in other formats as well. .doc, .docx, .html, or even as a plain .txt file. There are libraries for this on the web. If this kind of functionality interests you and you would like to add it to the app. We can now say that our application is actually useful for something. It can produce PDF documents from the browser. We'll continue exploring the options for real-world usage in the next and final section of this course. What we did and learned in this section: using external libraries, modifying our app for rich text editing, and exporting documents to PDF. Thank you for watching. See you next time when we wrap this course up. Hi again! In the last section, we came to the point when we were able to export documents from our app in the form of PDF files. In this section, which is the final section of our course, we'll wrap things up by further exploring use cases for the app. We can imagine hundreds of different uses for the documents in our app, but we'll explore the following too: exporting our documents and using them in a blog or a web page. The first one we've already made possible, although in a single format. PDF is a great format if we need a portable document for read-only uses. For everything else, it would be good to explore other options. The second use case we'll explore is posting to a remote blog or web page. This can be done in multiple ways and is tied to the previous use case. One of the examples we'll go through is posting to a WordPress.com blog to demonstrate how things might work. Like previously mentioned, we should explore additional options on how to use our documents outside of the app. Using some HTML5 magic, we can save our documents in any format we see fit. Solving this is done in two parts: getting and encoding the data from the document first and redirecting the browser to the generated data URL for download. Before we get into the specifics, we'll need to adapt the document item view. Export PDF, export HTML, and export text. Just a moment, export PDF. To achieve this, we'll simply add more options. Besides PDF, we'll add HTML and TXT. When we started this course, I mentioned that it would be best to use a modern browser, and finishing this chapter depends on it. Most browsers should have no problem handling this functionality, with one notable exception: Internet Explorer 9. If you happen to use Internet Explorer 9, you'll either need to upgrade your browser to Internet Explorer 10 or use a different one for this chapter. The reason we need a modern browser is the need for the blob API in HTML5. Using that, we'll be able to generate any type of file imaginable from our app. The blob API is a relatively new API which allows us to work with file-like objects of raw data. For all intents and purposes of our app, we will treat them as like actual files. Some more information on the subject can be found at https://developer.mozilla.org. After hooking in the events and determining what exactly the user is trying to achieve, we continue to the exporting part of our app. When export text, when export HTML. Starting with the plain text files, we'll first need to set their MIME type. For those unfamiliar with the concept, MIME types are simply a way for the browser to determine the type of file we're working with. You can find more on this topic at http://n.wikipedia.org/wiki internet media type. The MIME type is a simple string, which for text files is text/plain. There are other options that can be set here, but we'll keep it as simple as possible. Next, we need to get the content we want to export, in our case, located inside the HTML element on screen. However, we'll get it by using .text instead of .html, because we only need the textual content. And .txt files don't understand markup and will see it as text, providing us with a rather messy output. So, by selecting article element and extracting its contents by using .text, we get the desired result. Text equals @element.find article.text. File equals new blob. Text type equals text/plain. .txt URL.create object URL file link click. True. With those in place, we can now generate an actual file by using the blob API. The constructor for a new blob requires only the contents and the MIME type, giving us a binary representation of our data. In other words, an actual file inside our browser. What remains to be done is sending that file to the desktop. We can achieve this by using the download attribute inside an A element, which we already placed in the template. Extracting the blob's data URL and setting it to the A element gives us the desired result. As we can see, opening the file in a text editor on the desktop gives us the same content we had inside the browser. This has its uses, but it isn't the easiest thing to read, mostly due to the lack of formatting, which leads us to our next task in this chapter, exporting a file as an HTML. Most of the work to complete this has already been done. We can reuse what we did with the textual file export with two differences. First, instead of getting the text by using the .text method, we'll use .html instead to extract the entire markup, and second, we'll set the MIME type to text HTML. Besides this, the procedure remains the same. HTML, HTML, and HTML. Testing the file produced in this manner gives us a nicely formatted file on screen, viewable in any browser and editable in any text editor. Learning how to export our files gives us the tools necessary to send them to a blog provider such as WordPress, which we'll explore in the next part of this section. Publishing our files online should now be a simple task. We can achieve this in two ways. The old-fashioned, copy and paste the markup inside our WordPress admin area, or the more sophisticated way by using the REST API. This would be a rather simple matter if not for the same origin policy in place by WordPress. In short, it doesn't allow AJAX requests outside its domain. Security-wise, this is a sensible limitation. Circumventing this limitation will require some work on the server. But fear not, this isn't going to be something too complicated. Most of the prep work for starting our own server has been done. We've already installed Node.js on our system. We'll start by creating a new directory in the root directory of our app, called server. Inside the directory, we'll create a separate application, which will take care of sending data to a WordPress blog. Before writing the code for it, we'll need to create a package.json file, which will tell npm, the bundle package manager, what our app requires for working. We'll need one external component for this, a package called Node WordPress. Our microserver will be consisted of a single file, called server.coffee. There are two important parts here. Server.coffee. Intercepting a request made by our app and passing that request to a WordPress blog, configured by the following options: URL, username, and password. Once the request gets sent, it creates a new post in the WordPress blog. Looking at the bigger picture, this is simply a matter of putting the right things into the right places. The title and the content fields are obvious. The status should be set to publish, since we wish to publish the article, but this can easily be changed to draft. Now, we need to run the server by executing coffee server.coffee in the console inside our newly created server directory. On the client side, similar to what we did with exporting files, we add one more button to the document item view, the Publish button. Publish and publish. When publish, what remains is hooking an event to the new button, which will collect the content from the article element and send that content to our micro server. Title equals at element.find article.html. Content equals at element find article h1.text article.html jQuery.post http localhost 8080 title equals title, content equals content, response, alert, published, call, documents. Back to our app. If we press the publish button on a document, it publishes the document on the WordPress blog. Now that we know how to publish our documents to a WordPress blog, let's take a look at what's next in store for our app. As I mentioned on a few occasions through the course, the app has a lot of room for improvement. The idea was to give the viewer a starting point of some kind, so you could make your own version of your app. I encourage forking the app on GitHub and making it your own in any way you see fit. The finished standalone version of the app is located at https://github.com/dobozhinovsky/awesomepad. There are many ways of improving it and many things you could add to it. Perhaps an offline blog editor of some kind, a new note-taking app, a clone of the Google Docs, even a mail client of some kind. Additionally, I would like to suggest exploring the available JS frameworks and rewriting the app in one of them. What we wrote is for educational purposes only, and has a lot of room for improvement on many levels. In a manner of speaking, we were reinventing the wheel in order to learn how the wheel works. So now that we have some basic understanding of that, we can move on to using a better wheel. In this chapter, the final one in this course, we went through some scenarios about how we might use the app in a real-world setting. We looked through content publishing and got an in-depth look on exporting files. I hope you enjoyed the course and learned something useful from it. Thank you for watching and happy hacking!